Data structures are not static artifacts. They live inside systems that evolve, people who change processes, and environments that shift. When structure and reality diverge, we call that failure and drift, and it's one of the most common sources of invisible, long-running bugs in data systems. Start with two simple ideas. Failure is when structure no longer supports correct operation. A foreign key constraint breaks, a join returns unexpected duplicates, or a report stops matching reality. Drift is a gradual shift. Schemas change, units creep, cardinalities evolve, semantics slide, and the structure that once fit the domain no longer fits. A useful metaphor is a bridge built for certain loads. If traffic patterns change, or heavier vehicles appear, the bridge doesn't fail overnight. It strains slowly, bolts loosen, cracks widen, and eventually the bridge becomes unsafe. Structure failure and drift in data systems follow the same pattern. Let's unpack the common forms this takes. First, schema drift. Producers change field names, types, or optionality without coordinated updates to consumers. A previously numeric column becomes a string, a timestamp's time zone changes, or a nested object is flattened. Pipelines start producing subtle errors, downstream consumers silently drop or misinterpret values, and dashboards become misleading. Second, semantic drift. Fields keep the same name but their meaning changes. A status code that once meant draft/published acquires new values for archiving or regional workflows. Because syntactic validation still passes, semantic drift is especially harmful. Systems behave confidently but are interpreting different realities. Third, cardinality drift. Assumptions about counts break. A field previously unique begins to duplicate. Nested lists grow from expected small sizes to very large ones, or the number of partitions exceeds expectations. Performance degrades, joins explode in cost, and indexes become inefficient. Fourth, dependency and coupling failures. A central lookup table or microservice becomes a single point of change. When many parts of the system depend on it, any change propagates widely. Uncoordinated updates cause cascading mismatches, contract violations, and silent data loss. Fifth, temporal and ordering drift. Time-related assumptions break when event producers introduce reordering, change timestamp resolution, or migrate to a different clock. Causal analyses and time-windowed aggregations become incorrect. Sixth, tooling and environment drift. Upgrades to libraries, serialization frameworks, or database engines can alter default behaviors, different rounding rules, new null handling semantics, or change default encodings. These differences are small, but multiply across pipelines. Why are these problems so insidious? Because they are often silent. Data still flows. Tests that check only syntactic shape pass. The system continues to produce outputs that look plausible, and only domain-level checks or manual inspection reveal the mismatch. By then, analytics, models, and even production decisions may have been affected. So how do you detect structure failure and drift early? Start with schema and contract monitoring. Track schema changes in a registry, compare versions, and alert on incompatible edits. Enforce compatibility rules for producers. Additive changes are allowed, removing or changing type semantics requires coordinated migration. Instrument semantic monitoring. Beyond shape, monitor field-level statistics, null rates, distinct counts, value distributions, cardinality, and typical string patterns. Sudden jumps or slow trends are red flags. For example, a spike in nulls or new categorical values should trigger investigation. Build behavior-level checks. Write assertions for business invariants. Totals should sum within tolerances, counts should be monotonic where expected, and ratios that usually sit in a narrow range should be watched. These checks expose semantic drift that shape checkers miss. Test and validate in staging with real-like data. Replay production traffic into canary environments, run full pipelines, and compare outputs to known good baselines. Contract tests between services prevent silent schema mismatches. Adopt lineage and provenance. Track where each value came from and how it was transformed. When drift is detected, lineage lets you localize the responsible producer or transformation quickly. What about remediation when drift or failure is found? Prefer automated containment first, quarantine affected records, reject malformed messages at the edge, or route suspicious data to a repair queue. That prevents bad values from polluting downstream systems. Provide reconciliation paths. Design idempotent replays from source of truth logs or event streams, and keep raw, immutable payloads so you can rederive correct state once fixes are applied. When semantics change intentionally, run coordinated migrations. Add new fields rather than rename or repurpose existing ones. Backfill historical data, switch consumers to the new fields, and then retire the old representation. Communicate changes with owners, version schemas, and provide a deprecation window. Reduce coupling and blast radius. Use clear contracts, versioned APIs, and transformat-ingest patterns so internal changes can be normalized before they reach many consumers. Finally, cultivate organizational practices that prevent drift. Designate schema owners, require change reviews for non-trivial edits, publish migration playbooks, and run regular audits of field usage and assumptions. Make schema changes visible, logged, and monitored like any code change. In short, detecting and managing structural failure and drift is not a single tool, it's a discipline. It combines schema governance, continuous monitoring, behavior-level assertions, replayable raw data, and coordinated change processes. When teams treat structure as a living contract rather than a static artifact, they turn drift from a surprise into a predictable engineering process. That shift makes data reliable, systems resilient, and downstream insights trustworthy. So the next time a report doesn't match intuition, or a model silently degrades, don't just blame the code. Trace the structure, look for drift, ask how the bridge was built, what loads have changed, and whether the bolts have loosened over time. That's where reliable fixes begin.